So you can see on the front of this instrument there's a dome-shaped device. That dome is a special vessel which is made so we can control the atmosphere inside, and it's fabricated from beryllium metal.
This is the beryllium, which I don't really want to get out.
Why not?
Because it's a toxic chemical, toxic metal.
Beryllium is an interesting element because most chemists don't really know about it very much at all.
So beryllium is a fantastic metal. It's really, really interesting. It's got lots of really quite strange metallic properties, but one of the most important for me is the fact that it's transparent to X-rays, so I can shine X-rays straight through the beryllium, and the beryllium doesn't absorb it at all, which most other metals, especially those with higher molecular weights, do.
Beryllium-laden dust actually has been shown to cause berylliosis, which is actually an industrial lung disease, which causes the formation of sort of swollen nodules in the lungs called granulomas, which is a bit gross. So I don't really want to open up the jar.
It's near the beginning of the periodic table, but we rarely come across it.
So at the moment we're at Max Lab and we're doing some X-ray experiments, and we're doing some X-ray experiments on a really, really quite sensitive compound. So X-rays themselves are absorbed by everything. Okay, so when we shoot it through the air, it's absorbed in the air. So to measure the X-ray absorption of our compound, which is sensitive to the air, we need to be able to remove the air and encase it. So we use beryllium to make a magic box around our sample that the X-rays can come into, interact with our sample, and then exit without interacting with the material around them. So you can see on the front of this instrument there's a dome-shaped device. That dome is a special vessel which is made so we can control the atmosphere inside, and it's fabricated from beryllium metal.
I talk about in my lectures, I explain that beryllium chloride, the molecule that has 3 atoms, 2 chlorine atoms and 1 beryllium atom, has the 3 atoms arranged in the row. So it's a straight molecule, so-called linear molecule. But I've never seen beryllium chloride.
Chemists use it on X-ray diffractometers because actually it's so lightweight. It's actually only got atomic number 4.
The beryllium allows the X-rays to come in and out without interacting at all. It's a fantastic device. It's really useful for really sensitive chemistry. It's a really beautiful application. The cost of that beryllium, though, that's significant. That small beryllium sample cost €15,000.
It only has 4 protons and a number of neutrons. So if X-rays fall on atoms of beryllium, they're not scattered very much. So it's like the difference between shining light through a glass window, and if you made it out of a heavier material, it'd be like shining through paper. It would be scattered. You wouldn't get a good image.
I'm hoping to actually do some chemistry with beryllium, which is why I've bought it. Yeah, it's pretty toxic, so we're going to have to be very, very careful. You can't actually breathe in the dust at all, because even actually one exposure has shown that some people, one exposure is enough to cause this sort of sensitive reaction.
But beryllium's very poisonous, so if you do use these beryllium windows, you have to be careful not to lick your fingers. Well, good chemists shouldn't lick their fingers anyway.